Hi all, this is lecture and guided practice combined 14. I'm talking about from section 4.4, higher order derivatives. Now I condensed this just a little bit because this is kind of a bonus topic from section 4.4. And it really isn't adding anything significant to our derivative rules. The only thing we're going to talk about here is that there are derivatives beyond the first derivative. So far, we've been finding f prime of x, right? And so from now on, we're going to call that the first derivative because you're taking the derivative one time. But there's no rule that says you can't keep taking derivatives of functions. And so if you take the derivative a second time, that's the second derivative, and we note that by using two dashes or two primes. If you take it a third time, it's the third derivative, and that's triple prime. Once we get to the fourth derivative, we stop using primes because we don't want it to take up too much space, and we just put a 4 in parentheses within the function notation. Which means that the nth derivative, meaning, pick a number, right, is f of n, right, as an exponent with parentheses. Particularly the first 2 or 3 have meanings within, for example, physics. So the first derivative of position is speed or velocity, and the second derivative would be the acceleration, and I believe the third derivative is, torque, but I'm not sure about that one. We clearly don't use it often. Okay, but there are also ways that we approximate things later in Calc 2 that use multiple derivatives like this. So you can keep taking derivatives, okay? And all you're doing is taking your function, that is the first derivative, and then taking the derivative again. So if I take a look at this first function, we've got negative 3x cubed plus 24x squared plus 6x minus 64. If I take the first derivative like we've been doing, I use my power rule. And so this becomes negative 9x squared plus 48x plus 6. Then, if I want the second derivative, I use good notation. That way we know which one you're talking about. And I'm going to take the first derivative, the negative 9x squared plus 48x plus 6, and I'm going to apply my rules again. So using my power rule, this is negative 18x plus 48. And then my third derivative would be to take the derivative of that, and that's just negative 18, right? And if I went to a fourth derivative, even though they didn't ask for it, it would look like this, and it would be 0, and all the ones after that would be 0, okay? Now, what you have to remember is that in this case, each derivative was just a polynomial, so I could use the same kind of rule each time. However, as your function changes, it could look different after the first derivative, and you might need different rules. So you need to reevaluate every time you take a derivative. So for example, in number 2, when I go to find the first derivative, I see that this is going to be a chain rule because I've got an inside function and an outside function. So the first derivative here is going to be 5x squared plus 3 to the 4th times the derivative of what's inside, which is 2x. So now I'm going to put these two together and make it 10x times x squared plus 3, to the 4th, okay? And that means that when I go to take the next derivative, now I've got two functions being multiplied together because I have an x on the outside. If that were just a 10, then I could just apply my rule again. But because there's an x there, I'm now multiplying two functions. So in order to find the second derivative, I'm going to go over here, and I've got to have function 1 is 10x, and its derivative is 10. Function 2 is the x squared plus 3 to the 4th, and I need a chain rule here to find the derivative. So 4 times x squared plus 3, decrease your exponent by 1, multiply by the 2x. So this is 8x times x squared plus 3 cubed. So then we can put all of that together to get our second derivative. So our second derivative here, 1 prime 2 is going to be these two. So 10 times x squared plus 3 to the 4th plus these two multiplied together. So that's going to be 80 x squared and x squared plus 3 cubed. Now, if we want to factor this and make it pretty, both terms have, let's see, a 10 out of here. And then both terms have the x squared plus 3. So I have a 10 in common from the blue parts. And then we have an x squared plus 3, and they both have at least 3. And when I look at what's left, I have an x squared plus 3 out of the first term and an 8x squared out of the second term. So that gives me 10 times x squared plus 3 cubed. And we've got 9x squared plus 3. Okay. Now notice that our derivative in this case gets more complicated as we go. And so hence why I didn't ask you to take more than the first and second derivative. Okay. In this case, I would need product rule and chain rule again. But we're going to stop there. Okay. But keep in mind, to reevaluate each time you take a derivative, your function might look different structurally and might need different rules. Number 3 is a quotient rule. So to get our first derivative, we need top prime bottom. So top is x squared, top prime is 2x, the bottom is x minus 1, and the bottom prime is 1. So my first derivative, top prime bottom, is 2x times x minus 1, plus these two is x squared, minus x squared, all over x minus 1 squared. Do not cancel these two, right? That top is connected with the minus sign, so that's not eligible to be canceled. I know it's tempting, especially when they're sitting right above each other like that. What we're going to do instead is multiply everything out. So 2x squared minus 2x minus x squared all over x minus 1 squared, which we're going to say is going to be x squared minus 2x all over x minus 1 squared. Okay, that's my first derivative. So now I need the second derivative. In order to find the second derivative, I need quotient rule again. So my function 1 is going to be we're doing tops and bottoms here. So top is x squared minus 2x, and the top prime is 2x minus 2. The bottom is x minus 1 squared, and the bottom prime, this requires chain rule, bring down your 2, x minus 1 to the 1 times 1. Okay, and this we put all together using our quotient rule. So we've got top prime bottom. So top prime is the 2x minus 2 times the bottom, which is the x minus 1 squared, minus 2 times x minus 1 times x squared minus 2x, all over x minus 1 squared, or to the 4th. Now, you do have one of these in each position, right? And so you can cancel one of them. So this one of those, and one of those. That's going to leave me with 2x minus 2 times x minus 1 minus 2 times x squared minus 2x, all over x minus 1 cubed. From here, we're going to distribute everything. So 2x squared minus 2x minus 2x plus 2 minus 2x squared plus 4x, all over x minus 1 cubed. And take a look at this. Here we go. The 2x squareds cancel. 2x, and 4x cancel. And I'm left with just final answer of 2 over x minus 1 cubed as my second derivative. Okay, so 2 chain rules to get my 2 different derivatives. Okay, be sure to label them properly. And then this last one, during the construction of an office building, a hammer is accidentally dropped from a height of 256 feet. The distance in feet the hammer falls in t seconds is d equals 16t squared. What is the hammer's velocity when it strikes the ground? What is its acceleration? So if you heard me mention above, we know that d is for distance, and the derivative of distance, d prime of t, is the velocity. And the second derivative of d is the acceleration, the change in velocity or the acceleration. So it's asking, what is the hammer's velocity when it strikes the ground? What is its acceleration? Okay. So the first thing we need to know is how long until it hits the ground, right? So the height, think about a picture here. This is starting at distance equals 0 at the top, and our hammer is falling a total of 256 feet. And we want to know how long does that take, first of all. Okay, so that's the first question. So if we have d equals 16t squared, set our d equal to 256, divide both sides by 16, and take the square root. So that t is equal to 4. So 4 seconds. So 4 seconds to the ground. That's important for us to know. Then, what is the velocity when it strikes the ground? So after 4 seconds, what's the velocity? So our d is 16t squared. So we want to know the velocity, and the velocity is the derivative, first derivative. So that's going to give us 32t. And they want to know what is the derivative when it hits the ground, which is in 4 seconds. So the velocity at 4 is 32 times 4, or 128. And is this, this I think is in feet per second, right? And then they want to know what's the acceleration. So the acceleration, or a of t, equals the second derivative of our position. So if we take the derivative of 32t, that's just 32. And so that's our answer, 32 feet per second squared. There's nowhere for me to plug in a time unit. So the acceleration is always 32 feet per second, which just happens to be the acceleration due to gravity, right? So 9.8 meters per second, or 32 feet per second squared is the acceleration due to gravity. So those are our two answers for this one.